Hi students, welcome to my teacher channel. In this video, we are going to solve the problems given in exercise 1.1 of real numbers chapter from ninth class mathematics. Now, in exercise 1.1, the first question is like this. Write any three rational numbers. So children, we know what are rational numbers. Rational numbers can be integers or fractions or decimals. So let me take an integer as an example, like -3, and a fraction 1 by 2 and a terminating decimal 0.1. So these are the examples for rational numbers. You can try to write many more of your choice because there are innumerable rational numbers present. Now, the second question, explain the rational number in your own words. So, we have already seen what is a rational number. So, now it is your turn to explain the rational number in your own words. Try. Before solving the second question, now, let us put the number system, represent the number system in a picture. Like, we'll start with natural numbers. We all know that natural numbers are all the counting numbers, like 1, 2, 3, 4, and so on. So let me take a small circle which contains all the counting numbers 1, 2, 3, 4, and so on, and this circle represents natural numbers. N. Whole numbers. See, whole numbers is a set which contains all the natural numbers and 0. So 0 is an extra number which is there in whole numbers. So 0 is a little bigger set than natural numbers, and that is represented by W. Now, all these whole numbers and negative integers together called as integers. So integers is a bigger set which contains natural numbers, whole numbers, and negative integers. Now, these are all integers. These integers can be represented in P by Q form, where Q is not equal to 0 and PQ can be any integer, right? So that means all the integers are rational. What are the numbers present between two integers? Yes, there are many rational numbers present between any two given integers, but those rational numbers can be expressed in the form of fractions or decimals. So these decimals, fractions, and integers all together called as rational numbers. So now let us put this picture into our learning board. Now we'll go to the second question from exercise 1.1. Give one example to each of the following statements. Now the first statement from this question is like this. A number which is rational but not an integer. Children, we have seen all integers are rational, but here the statement is like this. A number which is rational but not integer. So what are the numbers which are not integers but rational? Yes, those numbers can be expressed in fractions or decimals. So you can write any fraction as an example to this, like 1 by 2, 2 by 3, or any fraction where Q is not equal to 0. That you have to remember. And any terminating decimal or non-terminating repeating decimal also you can take. So the example for this can be any fraction 1 by 2, 2 by 3, or anything, or any terminating decimal 0.1 or 1.2 or something like this. Okay. Now the second statement from this question is like this. A whole number which is not a natural number. Let us bring back the picture that we have kept in the learning board in the beginning. Right. So in this, see, natural number set contains 1, 2, 3, 4 and so on, and whole number contains 0, 1, 2, 3, 4 and so on. So 0 is the extra number which is not natural. See children, in this picture you can clearly see that 0 is a whole number, but 0 is not there in natural number set. So the example for this statement will be 0. Yes, 0 is a whole number but not natural. Now the third statement is like this: an integer which is not a whole number. So we know that all whole numbers are integers, but what are integers? Let's bring back the learning board chart. Yes, see here, all the whole numbers are there in integers, but other than whole numbers, the negative numbers are also there in integers. So all these negative integers are integers but not whole number. So the example for this statement can be any negative integer, like -1, -2, -3, anything. So let me put -1 there as an example. Now the fourth statement is like this: a number which is natural number, whole number, integer and rational number. So now we have to give an example which satisfies that it belongs to natural numbers, whole number set, integers and rational number set. So you can take any natural number, automatically it becomes whole number and integer and a rational number. So the example for this statement can be any natural number. So 1, 2, 3, 4, so on, anything you can take. Let me take example as 1. Now the fifth statement is like this: a number which is an integer but not natural number. So take any number which is not natural number. It can be 0 or negative integer. So example for this is either 0 or any negative integer. Let me take as -2. So -2 is an integer but not a natural number. The third question is like this: find 5 rational numbers between 1 and 2. We need to find 5 rational numbers between 1 and 2, isn't it? Yeah. So let me write the given numbers 1 and 2. Okay, and we are going to convert these numbers into fractions. So 1 can be written as 1 by 1, which is nothing but 1 again, and 2 can be written as 2 by 1. How many rational numbers do we need to find between 1 and 2? Yes, we need to find 5 rational numbers. Yes. So if we need to find 5 rational numbers, then we have to make the denominators into 6. 5 plus 1, 6. So let me write like this: to find 5 rational numbers between 1 and 2, multiply numerator and denominator with 5 plus 1, 6. So how these fractions are going to change? Let's see here. 1 by 1. 1 is nothing but 1 by 1, and we are multiplying the numerator and denominator with 6. Then it becomes 1 6 are 6 and 1 6 are 6. 6 by 6. Okay? And now 2, we wrote it as 2 by 1, and we have to multiply the numerator and the denominator by 6. So let me multiply here. 2 6 are 12, 1 6 are 6. Now 1 is nothing but 6 by 6 and 2 is nothing but 12 by 6. Now between 6 by 6 and 12 by 6 there will be 5 rational numbers. So let me write them like this. So 1 is nothing but 6 by 6, which is less than 7 by 6, which is less than again 8 by 6 is less than 9 by 6 is less than 10 by 6 is less than 11 by 6 is less than 12 by 6, which is nothing but 2. So between 1 and 2 we have found 5 rational numbers. 1, 2, 3, 4 and 5. Now the fourth question is like this. Insert 3 rational numbers between 3 by 5 and 2 by 3. So let me write the given fractions like this. Given fractions. What are they? 3 by 5 and 2 by 3. Great. Now, children, to find any rational number between the given integers or between given fractions, you need to keep one thing in mind, that the given fractions must be in like fractions form. Means the denominators of both the fractions must be same. Now, are these denominators same? No, one is 5, the other one is 3. So first, let me convert them into like fractions. How are we going to do that? See here. So first, let me take 3 by 5 and multiply with 3. Means multiply the numerator and denominator with 3 into 3 by 3. Then it becomes 3 3s are 9, 5 3s are 15. Okay. Now let me take the second fraction, 2 by 3. Now for this fraction, let me multiply both numerator and denominator with 5. Yes, 5 and 5. Now it becomes 2 5s are 10 and 3 5s are 15. Now see here, both the fractions have the same denominator, 15 and 15. Now that means these are like fractions. Okay. Now, how many rational numbers that we need to insert between the given one? Yes, we need to insert 3 rational numbers. So to insert 3 rational numbers, let me multiply both the fractions with 3 plus 1, 4. Okay. So same thing, let me write here like this. To insert 3 rational numbers, multiply both numerator and denominator by, so we need to get 3, that means 3 plus 1, 4. So this we have to keep in mind. If you want to insert 3 rational numbers, you have to multiply both the numerator and denominator with 4. Suppose if you want to insert 5 rational numbers, 5 plus 1, 6. With this number, you have to multiply both numerator and denominator of both the fractions. Okay. Now, let me take 9 by 15 and multiply both numerator and denominator with 4. Then this becomes 9 4s are 36 and 15 4s are, yes, 16. Okay, now let me take the second fraction, 10 by 15, and multiply both numerator and denominator with 4. So 10 4s are 40, 15 4s are 60. Now, between these two fractions, the denominators are same, 60 and 60, and numerators 36 and 40. What are the numbers between 36 and 40? 37, 38, 39. Yes. So 3 numbers are there between these two fractions. So those are the 3 rationals between the given fractions. So what are they? Let me take this. The first one is 3 by 5, and I converted that 3 by 5 as 36 by 60, which is less than 37 by 60, is less than 38 by 60, is less than 39 by 60, which is less than 40 by 60. 40 by 60 is nothing but 10 by 15, and that is nothing but 2 by 3. Okay, so between 3 by 5 and 2 by 3, we have found 1, 2, 3 rational numbers. The fifth question is like this. Represent 8 by 5 and minus 8 by 5 on a number line. So, to represent that one, first we need to take a number line. And in the middle of it, let me mark a point and name it as 0. Now, carefully look at the numbers that we need to represent. Yes, these fractions have 5 as denominator. That means each unit has to be divided into 5 parts. Okay, and on both sides of this 0, we have to take the divisions because we need to represent a positive and a negative fraction also. Okay, now towards right side of 0, let me mark here each unit is divided into 5 parts like this. 1 by 5, 2 by 5, 3 by 5, 4 by 5, and 5 by 5, which is nothing but 1. Okay, now 6 by 5, 7 by 5, 8 by 5, 9 by 5, and 10 by 5, which is nothing but 2. Now on the left side of 0, negative ones. Minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 5 by 5. Yes, minus 5 by 5 is nothing but minus 1, minus 6 by 5, minus 7 by 5, minus 8 by 5, minus 9 by 5, and minus 10 by 5, which is nothing but minus 2. 5 2s are 10, isn't it? Now, what are we going to mark? Yes, 8 by 5 and minus 8 by 5. It's pretty easy. See, here it is 8 by 5, which is in between 1 and 2, and minus 8 by 5. Yes, and this is in between minus 1 and minus 2.